Hello my students, hello grade 5. This is our third online lecture, and in this lecture we are going to explain a new lesson which is divisors or factors. Of course, you have learned last year what's the meaning of divisors or factors, but this year I'm going to make a revision and do something new. So let us first the learning objectives are to recognize and list the divisors of a natural number. So you will be given a natural number and you have to list the divisors of this natural number. Then we are going to find the common divisor of two natural numbers. And the last thing, we are going to find something which is called GCD, or in another word, the greatest common divisor. Look at this table. The table contains numbers such as 5, 9, 8, 12, 7, 3, 2, and 6. Using those numbers, you have to match numbers into pairs that you multiply them together in order to get, in the first case, 63. So what are the two numbers that you multiply them in order to get 63? It's 9 times 7. So 9 times 7 give us 63. Now think of two other numbers. When you multiply them, you get 48. So those two numbers are 6 and 8. So 6 times 8 is 48. Now think of two other numbers. When you multiply them, you get 36. So the two numbers are 3 and 12. So 3 and 12 give us 36. Now think of two numbers. When you multiply them, you get 10. They are 2 and 5. So you have to keep in mind, whenever you multiply two numbers, suppose 9 times 7, it gives you 63. So we say that 9 and 7 are factors of 63, or divisors of 63. So as we said, the factors are the numbers you multiply together to get a product. For example, the product 24. So when you say 24, it has several factors, because some of you would tell me that 3 times 8 is 24. Some of you would tell me that 6 times 4 is 24. So 24, it has several factors. Let us see what are they. So first of all, 24 is 1 times 24. It's 2 times 12. It's 3 times 8. And it's 4 times 6. So all these numbers, when you multiply them, you get 24. So the factors are 1, 2, 3, 4, 6, 8, 12, and 24. It's so important to know that the factors are always written from the least to the greatest. Why? In this way, for example, you can see that if you multiply 1 times 24, it's 24. 2 times 12, it's 24. 3 times 8, it's 24. And 4 times 6, it's 24. So one from the left and one from the right. If you multiply them, you get 24. So those are called the factors, and they are arranged from least to greatest. Now, how can I find the factors of a certain number? Suppose you have any number. You start with 1 times the number, and then you try 2 times the number, 3 times the number, and 4 times the number. For example, when you repeat your factors, cross out the repeat, you're done at this point. If you get doubles, such as 4 times 4, then you are done, and repeats or doubles let you know that you are done. Guys, I'm going to give you an example, but you have to keep in mind, when you repeat your factors, you cross out the repeat and you are done. So when you repeat your factors, you cross them, and you stop. And when you get doubles, such as 4 times 4, that means you are done. Of course, you are asking, what does that mean? I will give you examples, and you are going to get the idea. So let us start. What are the factors of 16? As I told you, you start always by 1. What's the number you multiplied by 1 to get 16? It's 16. So 1 times 16 are the first pair. Then you ask yourself, you try 2, 3, 4, and so on. 2. Is there a number you multiplied by 2 to get 16? Of course there is. It's 8. It's 2 times 8. And now you ask yourself, is there a number you multiplied by 3 to get 16? It's not. So what do? 3 is not a factor, so we cross it out. And we continue till 4. What's the number you multiplied by 4 to get 16? It's 4 times 4. What did I told you in the previous slide? I told you, whenever you reach the double, you stop. So here you have double. You have the same number twice. So that means that you have to stop. So double, done. Doubles means you are done. So the factors now are 1, 2, 4, 8, and 16. You don't try the number which is double twice. So the factors are these: 1, 2, 4, 8, and 16. Don't forget to arrange them from the least to the greatest. Let us take another example so you would get it more. Now, what are the factors of 18? As I told you, you start by 1, then by 2, then by 3 until you are done. And there are only 2 cases to stop: when you reach a double and when you repeat a number. So 1 times 18, it's 18. 2 times 9, it's a pair of factors. Now, is there a number you multiplied by 3 to get 18? Of course, it's 6. Now, 4 times what to give you 18? 4, it's not going to work out, so you cross it. Now you try 5. Is there a number you multiplied by 5 to get 18? Of course not, so you cross it. Now, 6. Is there a number you multiplied by 6 to get 18? Of course there is. It's 6 times 3. But oh, it's already written. So as if you are now going to repeat the numbers. So that means that you have to stop. Okay? So whenever you reach a number that you already write before, so you have to stop. So that means you have to stop. And repeat means you have to cross it out, and we are done. So the factors are 1, 2, 3, 6, 9, 18. So keep in mind, whenever you reach a numbers that you have already written, you stop, you cross, and you write the factors from least to greatest. Let us make another example. So what are the factors of 7? You start by 1 because 1 is the common divisor of all numbers. So what's the number you multiplied by 1 to get 7? It's 1 times 7. Then you continue. 2 times what equals 7? It will not work out, so we cross it. 3 times what? It's also not going to work out, so we cross it. 4 times nothing. Also 5 times nothing. 6 times nothing. But 7 times 1. But no, wait, you already wrote 1 times 7. So what you have to do is to work out, to cross out the 7 times 1, and you are done. So the only factors of 7 are 1 and 7. But wait, 7, it has only 2 factors, 1 and itself. What does that mean? That means that we have 2 types of numbers, prime numbers and composite numbers. Prime numbers are numbers that only have two factors, 1 and the number itself. Examples: 3, 5, 7, 11, 31. Those, what we call them, prime numbers. Prime numbers are numbers that have only 1 and themselves or itself as factors. What's the opposite of prime? The opposite of prime is composite. Composite numbers are numbers that have more than two factors. Examples: 6, 18, 30, and 100. So if you found, or if you find the factors of a number and you found that it has only two factors, one and itself, is it called prime number? Yes. But if it has more than two factors, it's called composite numbers. I wrote for you the numbers from 1 till 100, and we are going to check what are the prime numbers. What are all the prime numbers from 1 till 100? Okay? So, keep in mind that 1 is not a prime number. Why? Because the rule says that a prime number, it has 1 and itself. But 1, it's only 1 times 1. So 1 could not be pretended as, we cannot pretend it a prime number because it has only 1 as a factor. So it's not a prime number. Let us try a way how we can find the prime numbers from 1 to 100. Look what did I do for you. This is the numbers from 1 till 100. What we are going to do now is to color in number 1 as this is not a prime. So you know that 1 is not a prime number, so I'm going to color it. Now we are going to color all the numbers that are not prime, and what are going to be left are the prime numbers. The second thing I'm going to do is that I'm going to color 2 and its multiple. So I'm going to color all the multiples of 2. 2, it has 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. All of these numbers are the multiples of 2. I'm going to cross them out or to color them because they are not prime numbers, because at least you can divide them by 2, right? But I'm going to keep 2 because 2, it's only divided by, or it's only divisible by 2. We cannot divide 2, or we cannot have factors for 2 rather than 1 times 2, okay? So I'm going to keep 2. The same thing, I'm going to keep 3 because it's a prime number, but I'm going to color all the multiples of 3. And the multiples of 3 are 3, 6, it's already crossed out, 9, 15, 21, 25, 27, 33, 36, 39, and 42, it's already colored, 45, we have 48, it's already colored, 51, 57, 63, 69, 75, 81, 87, 93, and 99. All of these are multiples of 3. I'm going also to color all the multiples of 5. We still have 55, 65, 85, 95. Now, number 7 is a prime number. I'm not going to color it, but I'm going to color the multiples of 7. We have 49, 77, 91, and so on. So what's left in white are the prime numbers. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. Of course, you are not responsible for memorizing them, but I'm just going to, we are just trying to find them. How can we find the prime numbers? So what I want you to keep in mind is that prime numbers are numbers that only can be divided by 1 and themselves. So the only factors that they have are 1 and themselves. Now let us do this small exercise. It's true or false. You have to tell me Uh, you have to answer by true or false. Just a quick reminder that a factor of a number divides exactly into that number, leaving no remainder. So, is 4 is a factor of 20 or is 4 a factor of 20? Think of a number. Is there a number you multiplied by 4 to get 20? Of course there is. It's 4 times 5. So yes, 4 is a factor of 20. Is 3 a factor of 34? Is there a number you multiplied by 3 to get 34? There is not. So this is false. 1 is a factor of every number. So as I told you, 1 is a factor of for all numbers. So this is true. Every number is a factor of itself. Of course, this is true. Another word for factor is divisor. This is true. The factors of 16 are 1, 2, 4, 7, and 16. This is false because instead of 7 you have to put 8. So this is wrong. 3 times 6 is a pair factor of 18. This is true because 3 times 6, it is 18. Now, important points to remember before we continue. So we have learned till now that 1 is a factor of every number, and every factor of a number is an exact divisor of that number. And every factor is less than or equal to the given number. Number of factors of a given number are finite. If you can still remember, the multiples of a number are infinite or infinite because we cannot count them all. But the number of factors are finite. Now let us continue. What are the common factors? This is very easy. What does common mean and what does factor mean? Common factor means are factors that are found in 2 or more numbers in common. So if you found the factors of a first number and a second number, the factors that are found in both, we call them common factors. A small exercise about this one. What are the common factors of 16 and 24? So the first thing I have to do is to list the factors of 16 and list the factors of 24, then try to find the common factors. The factors of 16 are first 1 times 16, 2 times 8, 4 times 4. Whenever you reach a double factor, you stop and you write the numbers. So once you repeat a number, you are done. So the factors of 16 are 1, 2, 4, 8, and 16. Now what are the factors of 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6, and we are done because 5, it's not a factor, and 6, it's the repeated number, so we stop. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 14. 24. What are the numbers that are found in 16 and 8? 1, 2, 4, 8. 1, 2, 4, 8. So those are the common factors of 16 and 24. So the common factors are the factors that are found in 16 and 24. Or the common divisors, it's the same word. So 1, 2, 4, and 8. Now we are going to find something called greatest common divisor or greatest common factor or greatest common divisor. It's very easy. So the greatest common factor is the factor which is found in both numbers, but the greatest one. So the GCF or the GCD, it's greatest common factor or greatest common divisor. Let us find the GCF of 9 and 12. 1 times 9, 3 times 3. Double means done. So the factors of 9 are 1, 3, 9. What are the factors of 12? 1 times 12, 2 times 6, 3 times 4, and we are done. So 1, 2, 3, 4, 6, and 12. Now what are the common factors or common divisors? The common factors are 1 and 3, but the greatest common factor is 3. Now here you have an exercises. I'm not going to solve them. They are bonus questions. Those who are going to give me the answers in the live session, I'm going to give you bonus points. In the first one, you have to list the factors of 36, 18, 27. Then give me the common factors of 18, 22, 52, 36, 14, and 9. And in the last exercise, you have to give me the GCF of 25, 40, 30, and 42. As I told you, this is a bonus exercise. Now we have this exercise. We need to list the factors of 56, 48, 36, 81, and 144. Now, first of all, the factors of 56 are 1, 2, 4, 7, 8, 14, 28, and 56. The factors of 48, you do the same steps I explained already for you. So the factors of 48, as you can see, are 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. They are all arranged from the least to the greatest. Now the question is, what's the greatest common factor of 56 and 48? So we are doing the first two. The common factors, first of all, 1, 2, 4, 1, 2, 4. Here you have 8, 8. And what else? That's it. But the greatest one is 8. Now let us see the greatest common factor of 48 and 144. So we are doing 48 and 144. So the common factors here, you have 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. 8, here you have 8. 12, here you have 12 and 16. And you have here 24, 24, 48, 48. So those are the common factors, but the greatest common factor is 48. The same thing, but we are going to do for 36, 81, and 144. 36, 81, and 144. The greatest common divisor, first of all, here we have 1, 3, 1, 3, 3. You have also here 9, 9, 9. Do you think you have another common multiple between the common divisor for 36, 81, and 144? Those are the common multiples, but the greatest common factor is 9. And now, what's the GCF of 144, 56, and 48? The greatest one is, let us see first the common. Here we have 1, 2, 4, 1, 2, 4, and here you have 1, 2, 4. You also have, here you have 8, 8, and 8. What else? 14, you don't have here 14. 28, you don't have. 56. So the greatest common divisor or the greatest common factor is 8. And the same thing in the other two. And now, at the end of this lecture, you are able to list the factors of a number, check the common factors, and find their greatest common factor. That's it. Now I advise you to watch the lecture one more time, take notes, then go and solve the worksheet, and hopefully to meet you in the live session. Hello grade 5, how are you? This is our 5th online lecture. And in this lecture, I'm going to explain something new, which is the criteria of divisibility by 3, 6, and 9, and 4. We already learned the divisibility by 2, 5, and 10. And in this video, we are going to learn the tricks for 3, 4, 6, and 9. So first of all, I'm going to make a quick revision for divisibility by 2, 5, and 10, and then I'm going to teach you how do you find the divisibility by 3, 4, 6, and 9. So let us start by the division. So as I told you before, divisible means that a number divides equally into another number without a remainder. So the result will be a whole number. So first of all, or the first trick that we learned is the divisibility rule by 2. It's when the last digit or the ones digit is even. So if you have in the ones digit 0, 2, 4, 6, or 8, that means this number is divisible by 2. For an example, 1008 is divisible by 2 because the ones digit is 8, which is divisible by 2. And this number, it's also divisible by 2 because the ones digit is 6. That means this number is an even number. Now, divisibility by 5. A number is divisible by 5 if the last digit is a 5 or 0. As an example, 99 is not divisible by 5 because the ones digit is not 0 or 5, while 875, as you can see, it's divisible by 5 because it ends in 5. 1280, it's also divisible by 5 because it ends with 0. Now the divisibility by 10, we say that a number is divisible by 10 if the last digit is 0. So the number 70 is divisible by 10 because the ones digit is 0. 33,690 is divisible by 10 because the ones digit is 0. Also keep in mind that a number is divisible by 10 if it's divisible by 2 and 5 at the same time, because this number should be even and it should be divisible by 5, so the only common between them is to end with 0. Now I want to remind you of the multiplication table of 3. You know that 3 times 1, 3. 3 times 2, 6. 3 times 3, it's 9. 3 times 4, it's 12. 3 times 5, it's 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. And 3 times 10 is 30. But what if that's the multiplication table of 3 that you have studied? But what if, for example, I have a big number? How can I know that this number belongs to the multiplication table of 3? So we are going to learn a trick which is different from those of 2, 5, and 10. This trick says that, look at the first number, it's 3 standing by itself, 6 standing by itself, also the 9. But here you have 1 and 2. If you add them together, 1 plus 2, you are going to get 3. Okay. Now if you add 1 plus 5, you are going to have 6. Now if you add 1 and 8, you're going to have 9. As if I'm trying to see something, let us continue. Now 21, if you add 2 plus 1, you are going to get 3. 24, if you add 2 and 4, you are going to get 6. 27, it's 9. And 3 plus 0, it's 0. So what you can see now is that this is 369, 369, 369. Okay, what does that mean? Well, in order to know that a number is divisible by 3, what you have to do is to add the digits of the number. So you have to add the digits of this number. So the digit sum is 3, 6, or 9, then this number belongs to the multiplication table of 3. So, as a rule, the digit sum is when you add the digits in the number repeating themselves until you get only one digit. Like for example, you have here the number 1467. If you add the digits, so I'm going to add 1 plus 4 plus 6 plus 7. Those are the digits of the number. If you add them, I got 18. If you re-add this number, 1 plus 8, you're going to get 9. And then it's divisible by 3. So keep in mind, the sum should be 3, 6, or 9. Then I will say that this number is divisible by 3. Okay, so till now we learned 2, 5, 10, and 3. So 3, it's new. You have to add the numbers, the digits in the number. If you got 3, 6, and 9, then the number is divisible by 3. Now, how can I know that a number is divisible by 6? It should pass the test for the divisibility by 2 and 3. So in another word, an even number with digit sum 3, 6, or 9 is divisible by 6. So example, you have here 930. Do you agree that 930 is an even number? So it's divisible by 2. Why? Because the one's digit is 0. Now I need to check if it's divisible by 3. What do? I add the digits. 9 plus 3, it's 12. Re-add the digits. 1 plus 2, it's 3. And 3, that means this number is divisible by 3 and 2 at the same time, so it's definitely divisible by 6. Actually 6, you can write it as 2 times 3. So if the number is divisible by 2 and by 3 at the same time, then definitely it's divisible by 6. Also the second number, which is 6,000. If you add all the digits, you're going to get 6. Then this number is divisible by 3. And it has 0 in the ones digit, so it's divisible by 2. Divisible by 2 and divisible by 3 at the same time, then it's divisible by 6. So in order to check the divisibility by 6, the number should pass through the test of divisibility by 2 and 3 at the same time. And here we go for the trick of divisibility by 4. Now, divisibility by 4 is different than the divisibility by 3. Well, in order to know that a number is divisible by 4, the last 2 digits of the number is divisible by 4. So the ones and the tens together, you have to look them and check if they are divisible by 4 or not. We do the same thing, but for the divisibility by 2, we look at the ones. But if we want to check the divisibility by 4, we need to check the ones and the tens together. So for an example, 9,264. You look at the ones and the tens together. Is 64 divisible by 4? This is very easy to check. You just use the division, okay? Or if you study them, if you know them directly, that's perfect. If not, you can check it just by division, and it's very easy. So here 4 times 1, it's 4. You subtract them. 6 minus 4, it's 2. Then you bring down the 4. What's the number you multiplied by 4 to get 24? It's 6. So 6 times 4, it's 24. The remainder is 0. So if the remainder is 0, then this number is divisible by 4. Then the whole number now is divisible by 4. Another example, 1,209, 124. So this 24, you can know directly that it's divisible by 4 because 6 times 4 is 24. So the whole number is divisible by 4. So it's just enough to check the ones and the tens together. Another example, it's 216. You take in the ones and the tens together, it's 16. And 16, it's divisible by 4 because 4 times 4 is 16. So the whole number now is divisible by 4. And now the last trick, it's about the divisibility by 9. And the divisibility by 9 is similar to the divisibility by 3. Do you still remember how do we check the divisibility by 3? When we said that you have to add the digits, If you add them and you got 3, 6, and 9, then the number is divisible by 3. The same thing we are going to do in this one, but the sums should be 9. So if you add them, for example, we have 495. If you add 4 plus 9 plus 5, it's 18, and 18 is divisible by 9, so this number is divisible by 9. And another example, 999,918. So I'm going to add all digits. I'm going to get 45. If you add 4 plus 5, it's 9. So here the sum should be 9. The sum should be only 9 to tell that this number is divisible by 9. While in the divisibility by 3, 6, and 9, by 3, excuse me, the sum could be 3, 6, or 9. But in the divisibility by 9, the sum should only be 9. So now let us make a division for all the divisibility. So first we learn the divisibility by a number is divisible by 2 if it's an even number or the ones digit is 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of the digits is divisible by 3 or the sum is 3, 6, or 9. And a number is divisible by 4 if the last two digits or if the ones and the tens together are divisible by 4. And if it's divisible by 5, then the number ends in a 5 or 0. 6 if the number is divisible by 2 and 3 at the same time. 9 if the sum of the digits is divisible by 9. And the last one, which is 10, if the number ends in a 0.